Okay, yeah, we are good.
So you're going to run the slides for me. I don't know where to control this yet.
So you can still control the slides, I think, with the presentation laptop, and there could also be a clicker, I think. I'm not quite sure, but...
Oh, this is the one, okay.
Yeah.
No.
Or I just pass control to you directly, and you can control them from your laptop. So now you can control them from your own laptop.
Not really. There's this thing, it doesn't work.
That has to plug into your laptop.
No. So Lisha, if you join the Meet Echo session with your own laptop, then...
She is. I did.
So try to control the slides.
Oh, okay, got it from here.
Great.
We are 1 minute past the 9:30 starting time. So should we get started on time? Given we have a very tight agenda. So maybe let's get started, especially for the first 2 minutes, I guess it's not important. So welcome to the DINRG, yet another meeting, the IETF 120. Today we're gonna have 4 presentations and then followed by a panel discussion. Let's just go through them. The first few slides really reflect the policies that guide our effort. And we go through them at every meeting. So everyone hopefully is already familiar with that. So let me just flip through that, understand all this privacy and the code of conduct rules. And then we talk about the goals of IETF. We are not producing standard, but rather we'll push forward in the research agenda. So now, administrative stuff. Everyone knows other things like the mailing list, the web, and the chairs, Dirk and myself. Now, critical step, we need to find a note taker. By the rules, we would not be able to move forward without a note taker. Any volunteers? Okay, great. We got 1 volunteer. Thank you so much. I actually don't know. There's always the first time for everyone. I suppose you know how to do it. Where is it? Grab someone who can tell you where to find the note page. Hey guys. Thank you very much. One thing I want to just say one word before we get fully started. We set up this publication page, I think 3 years back, in the sense that given that we do not produce a standard, but we do want to have a collection of publications in this area. We are not thinking about pushing all this new result report, observations, summaries, analysis, etc., going through the RFC series because it doesn't seem to be match the RFC intended goals. We are the research result. So our current solution about the shared publications and the knowledge information as going through this DINRG working research groups wiki page. And lately, if you have not noticed, we have put a number of recent publications in that page. The new measurement results and the new design effort towards decentralized application development. We would suggest that everyone, if you get the chance, please take a look to see what's the latest in this research area. So yeah, I think Dirk already put on I haven't looked at the slides before. How come okay. There's something going wrong with my laptop. I didn't get updated, but I noticed that there's update over there. So here's the listed recent additions to the publications. And as I mentioned before, you can explore at some later time. One more thing we want to inform everyone, and that is, given that it is a research effort, Dirk and I proposed and got accepted a workshop at the ACM CONEXT conference. It's one of the ACM top conferences in networking area. This will be held in December, mid-December at UCLA. And we run this workshop. The deadline is August 9th. It's getting a little closer, but still, with people's productivity here, I'm pretty sure if you have interesting position statement, preliminary results will be more than the most welcome for your contributions. I think we'll send you the pointers to the submission site as well, to the DINRG mailing list. So here is the current agenda. I already exhausted my 5 minutes there. So we're going to have 4 presentations today, as I mentioned before, followed by a panel discussion. The 4 presentations, the first 2 are all in the areas of what would be the identity or name or identifier solutions towards a decentralized system design. And then we follow that. There is this presentation by Shito, if I pronounce it right, about internet fragmentation on the analysis observation part. And then followed by a presentation of the SOLID project. SOLID is one of the best known and I think a long-lasting project in the broad areas of decentralization. It's really great. We'll get them to provide a description of that effort here. Then it will be followed by the panel discussion. Without further ado, we should get started.
Right. I prefer to, does this work actually?
That actually doesn't work. So maybe you can sit here. Oops.
Okay.
Yeah.
Okay.
You can just use this one. Oh wow, you can use.
I can just here. Hi everybody. This morning I swallowed slightly wrong, so my voice is a little funny because I was having some issues getting down here, but I'm very glad to be here sharing work that our community has done. My name is Kalia Young. My handle is Identity Woman. I've had that handle for 20 years because when I started, I was the only woman in the rooms working on digital identity that I'd met. And I've led the Internet Identity Workshop, where we've been innovating in this area for 20 years now. OpenID and OAuth were both sort of birthed at IIW, and OAuth is here at the IETF, as you know. And the rest of the presentation really talked about the innovations we've had over the last 10 years. I'm going to cover these 4 different protocols and then conclude by sharing more about where work is happening. So decentralized identifiers are one of our big innovations. They were approved by the W3C version 1.1, and there is a new maintenance working group currently in progress, along with a mandate to specify a resolution. So how are digital identifiers managed today? Sort of today, meaning perhaps 5 years ago, but there was not many choices when our community started work. There are private namespaces. These are controlled by various entities. So we have emails at Gmail and Twitter handles at Twitter and other places. But ultimately, our names within those contexts are owned by those platforms, right? So with the affect of the owners of the namespace, usually we can only communicate with people inside that namespace with the exception of email. You have globally managed registries. I know there's not, I keep forgetting to add the other end. I can, sorry, the slides keep going. But there is a universe of globally managed registries. These are broadly accessible. However, you usually pay rent to keep your identifier, at least the human readable ones. You're the affect and governance of the namespace. They are globally resolvable, and they provide the basis of global communications networks, but they have emerging security and fraud concerns. So how are decentralized identifiers different? Any entity can create one using software that they control, and there's an infinitely large namespace. So this is what a decentralized identifier looks like with scheme, method, and method-specific identifier. There is associated with every decentralized identifier a public key and a private key. And there is a JSON LD document describing the entity identified by the DID. So a DID document has these 6 main components: a DID for self-description, public keys for verification, the algorithms to verify the public keys, or verify the private key held by the controller of the DID, a set of service endpoints for interaction, a timestamp, and a signature for integrity. This is an example of a DID document with the ID, public key, RSA signature or RSA algorithm for authentication, service endpoint, when it was created, when it was updated, and the signature. This is from the DID specification. So you have a DID that's recorded potentially on a verifiable data registry, although that is not required. A DID points at a DID subject, which can be anything: a person, an entity, a pallet of goods, something on the internet. You have a DID document. You can resolve to find the DID document, and a DID controller can modify the DID document. In the reality and spirit of decentralization, the DID standard doesn't actually define a DID method, but it is more like an MVP for a DID method. There is a registry of decentralized identifier methods. At this point, there's over 180 in the registry. A DID method specification defines the syntax, any method-specific elements that are in addition to the required ones in the core specification, how you create, read, update, and delete decentralized identifiers and DID documents in the target system. Many DIDs are globally resolvable. Some DID methods anchor into public blockchains. Some exist into existing infrastructures like DID web, into existing DNS. Come on. Here we go. The Decentralized Identity Foundation maintains a code for a universal resolver. And there are companies like DINRG who have commercialized services in relationship to DID resolution. Some DIDs are not public. So DID peer is a non-public DID method suitable for peer-to-peer connections between people, and I'll share more about that and how it's used in the exchange protocol section. There's DID key, which is used to express public keys in a way that doesn't require a DID registry of any kind. So this is often used to as an identifier in the issuance of short-lived credentials in the verifiable credentials world. So DIDs are identifiers that are globally resolvable, decentralized, have associated public keys and endpoints, and therefore we have resolvable, decentralized public key infrastructure. DID DIDs are deep infrastructure and essential to reset the foundation and get beyond the two other choices we had before, which is private namespaces and globally managed registries. So there you have it, the DID. And who cares about really long numbers? You guys do. You guys all really care a lot. I know you do, but most people don't. So what are they good for? And why did we build this infrastructure over the internet identity workshop and its associated things? You have verifiable credentials, which was originally incubated in a community group at the W3C. It is in version 1.1. Version 2 is nearing completion. We have the SPICE working group that's just been started here at the IETF, echoing some of this work. And I have a report that articulates various flavors of verifiable credentials. This is a core model where you have an issuer that signs a verifiable credential. They give that signed blob of information about an entity to a holder. And the reason it's called a holder is because you might hold credentials that are not about you. They might be about another person, or another thing. Like pallets of goods can't hold their own credentials, like an entity that is helping manage them through the process is holding them. And then the holder can share information, share verifiable presentation of the verifiable credential to a verifier. In the earlier language of identity management, this would be the identity provider, and that would be, the verifier would be the relying party. But because we don't have a phone home model, notice how the issuer and the verifier are not actually connected or talking to each other. This is a different type of identity management model, so new words were appropriate. And the issuer anchors the public key material that they use to sign this credential somewhere, and the verifier can go look up the public key material associated with the issuer and then decide whether they believe the credential came from where it's claimed to come from, and also whether it's accurate. This is an example of a DID document in real life with all the pieces outlined. U.S. Department of Homeland Security has been involved in this work, and there is a plan to issue U.S. green cards using this format. You can see who issued the credential. They use the DID web method to anchor their public keys, the current status of the credential, who is the subject of the credential. They say, bring your own W3C decentralized identifier with you as the anchor. What they assert about the subject, which is their name, their residency date, their birth country, their birth date, etc., and how the verifier can go and get public key. Come on.
Yeah, the laptop has a problem. Okay, you can see that.
Yeah, I know. I'm trying to make it go forward. It's not going forward. Okay. Oh, now we're too far ahead. Just go one back. Okay. So it has a very broad expressive capacity and a huge range of use cases. The government of Bhutan is using this for the issuance of their credentials to their citizens. Taiwan is using this. California DMV is dual issuing in a format that ISO developed called MDL and the verifiable credential standard. All of the EU is mandated under EI-2 to adopt sort of dual issuance with verifiable credentials being one of the formats that is acceptable in the EU wallets. And I should just say, before we go on, there's also a lot of work going on using these credential formats for trade. I'm going to DM next because they're talking about credentials for goods. Exchange protocols, you have DIDCOM, OpenID for VC, and the combination. So DIDCOM messaging was developed to create peer-to-peer connections between two entities so they could share verifiable credentials. So you create a DID peer connection between two entities, and then you have a message exchange protocol that helps them connect. If you put this together with verifiable credentials, you can use these channels to exchange verifiable credentials. OpenID for VC was developed to leverage existing already OAuth capabilities, and basically a protocol has been developed to use these channels to issue credentials into wallets and also to share credentials from the wallet with a verifier. You have, and here's some links to go learn more. And then, so folks were, okay, OpenID for VC is becoming the norm for how you get wallets into and out of wallets, but what if you want to have an ongoing connection between an issuer and a holder? DIDCOM is a more appropriate tool, so there's been a lot of work on sort of fusing these together so you'd initiate the channel using OpenID and then move on to an ongoing connection using DIDCOM. And then you have this problem of who do you trust? So you've got governance registries for what types of entities are in a registry. How do you know where the public keys are, whether it's DIDs or X509s? What type of credentials do they issue? Are they higher education institution or not? How is the registry governed and what do they agree to? So you have sort of these ecosystems where you have issuers, holders, and verifiers. You have a trust registry, which tells you what type of credentials they issue and how it's governed. It has a governing authority. Like, think in higher ed, you already have this with in my state, California, there's a state level board that certifies entities that are higher educational institutions. These types of governance authorities already exist. They say, this is our framework for deciding who's in our ecosystem. Then you have the challenge of how do you find different registries, right? You're going to have more than one registry of higher education institutions in the world. So you're going to have different governing authorities, different trust registries. And my colleague Lucy in my consultancy has actually been working with UNDP to build out infrastructure for directories of trust registries. So these are the three centers of gravity in terms of orgs doing work in this space: the Credentials Community Group at the W3C, Decentralized Identity Foundation, Trust for IP Foundation. And the Internet Identity Workshop is a very good place to come and dive in the deep end of the swimming pool with all the folks working on all the things I just shared with you. That's our agenda wall we co-created each morning when we're there. Thanks very much. There's a couple minutes for questions.
Thanks, Kalia. So we have time for one quick question, and I see Raul in the queue.
If no question from the floor, let me ask one. So it seems that your registry.
So we have two people in the queue.
DINRG, this is some error on my side. It doesn't show join queue, yet I'm in the queue, so I don't have a question.
Okay, great. Then we take the next one. We have Jean-François.
Yeah, hi, Jean-François. You were mentioning about the global registry for methods. Where is that one stored? Or how is it managed?
It's managed, but I believe it's managed by the credentials community group. And if you type in DID registry, it should come up. I didn't put a link in the deck, unfortunately, but just look up DID registry.
But would that mean
DID
that
method registry will get you to it.
Sure, but is that a distributed database of some sort, or is it centralized somewhere?
It is a list managed by a community.
Just a list. Okay, thanks.
If I follow up that, who manages the community? That is, who are in or who are out of the community? I think that's a key point of the registries, because
So
names.
There's two types of registries. There's registries to manage governance of ecosystems, and then there is the list of DID methods, which if you meet the criteria for a DID method, you sort of knock on the door and say, hey, I have a new DID method, and they look at it, they'll let it into the registry. It's not strongly governed.
But it is governed.
It is governed
By whom?
by the credentials community group.
Who are those groups? Who can be in or out of group?
You can, it's a community group at the W3C, and you are free to join it and ask more questions.
Okay.
Hi, Michael Richardson. So I was involved in a verified credential demo last year. One of the kind of sticky points that I observed was wallets.
Yes.
Who's going to write them? Who's going to maintain them?
Yeah.
And me as an end user, how am I going to avoid essentially falling back into a oligarchy of Google versus Apple, and then who else is going to write a wallet that works right? Who's going to pay for it? And who's going to deal with the rendezvous needs of some of the wallets?
Right. So this is excellent questions. Those are all being actively grappled with. Within the EU, they have set out very clear requirements that wallets must meet. If certain oligopolies meet those requirements, they may be let into that ecosystem, but they are very cautious to avoid that happening. They have put millions of dollars into large-scale pilots and also reference code that's open source.
Right.
California has built its own wallet, which will be open sourced. So there is active effort to make sure there are more options in the wallet marketplace, and active conversations about how those are maintained, stewarded, and made available so that we avoid oligopoly problems. And we're out of time, so there's obviously more here. I'm happy to continue the conversation. And I think there's also this critical sort of work going on in a different working group or community group in the W3C about wallet invocation. So if I don't have an oligopoly wallet, how do I get to my wallet, and how does that user experience work? And it's actively being worked on by folks like Tim Capelli, who's here, and other folks in that community group, which is something like the web interface. I don't know the exact name of it, but it's in a community group at what's it called? The web interest community group in the W3C is where that wallet invocation stuff. And Apple and Google showed up at the last IW and jointly demonstrated things working using open standards.
Okay, thank you very much, Kalia. There are some links and comments in the chat as well, so if you want to check that out. We have to move on, so let's continue with Michael, who is going to talk about dance.
Hi, my name's Michael Richardson. Yeah.
So the question is whether Dirk can run this.
Does the clicker work for you or
I
not?
can tell you next slide. Or
Okay.
Does this work? Doesn't work, no, because it has to be paired to your laptop.
Paired.
Yeah, you have to pair it to your laptop, and you have to be running the presentation. Dirk, I'll just tell you next slide, please. Is that going to work?
That works for me.
Yep. Okay. Or I could use my phone. So I'm recycling slides from the dance working group from 112 because They asked me on Monday, and I really didn't have time to do any specific slides, so probably will skip the things. So this is actually good agenda. And actually, I would love to have stolen some of the slides from the previous presentations with our various, triangles of authority. Those are good. That's a good image. I liked it a lot. Next slide, please. Next slide, please. Okay, so particularly in a bunch of IoT spaces, we are often spinning up today private PKIs. This monitor just died. Okay. And did it die before? No, there it came back. And one of the issues is, for instance, if you're aware of a concept called an IDEV ID, which is an IEEE 802.1AR certificate. It's not very well defined, and about 90% of it are just pointers to RFCs. But when you get through that, you wind up with what's called an IDEV ID, and people or enterprises, makers will spin up a PKI, a private PKI, and they'll then stamp an IDEV ID in every device. That's true at some level for mobile phones. Some vendors have an IDEV, have a device ID in every phone. And there's also things where, for instance, there is, every batch of 10,000 phones has a certificate that attests to the fact that I'm a phone of a particular kind, and that's used in remote attestation. But every single one of these private PKIs it enforces its own namespace. Actually, that was perfect. You advanced exactly what I wanted. And I like that you read my mind. So the problem is each one of these are these PKIs, aside from being expensive to run, somewhat fragile, they also have this issue that they can only really effectively live in their own namespaces, but they also can't even defend the fact that someone else may wander on into their namespace. It's hard to do, right? You can put path constraints and other things like that, but that simply makes it more and more complicated. So there's lots of good things for it, and actually industry is moving very, I don't want to say quickly, but it's kind of like elephants don't move quickly, but you still don't want to be in a stampede of them. And that's happening, and that's it's good because they're actually putting identities. And 5 years ago, if I said you're going to put an identity in every device, about half the entities were like, no, that's too complicated. Well, and about half of them were already putting identities in their devices, and they didn't even know that. So then we have the thing, okay, I'd like to make a TLS connection. I'd like to make it to the other end, and I'd like to use the identity I already have. And how can I do that? Next slide, please. So next slide, please. So what we wind up doing is, what we're saying is, well, maybe what we shouldn't do is invent a new namespace every time. Maybe what we should do is use the namespace we already have. We use it for servers, and that's DNS. And so then the question is, okay, so how do I manage this? How do I put TLS identities, client-side certificates, and how do I indicate what's going on? So that's what the dance working group is about. And there's just, you think, well, isn't it just a solved problem? And yeah, there's just one or two little bits that we needed to add. Next slide, please. What we do is basically you now can add, instead of having to add, a strange DID with a long hex string, which maybe makes sense for a lot of privacy and people issues. It always doesn't necessarily make sense for devices which don't have the same kind of requirements, and particularly ones around your house or in an enterprise. It's like, well, no, actually what matters is I really need to know which device is which, and I really need to give them meaningful and useful names, because I need to be able to read those names out in like access control lists or something like, which button opens my garage door? Well, my buttons and not my neighbor's buttons, that's for sure, right? There's things like that. So there's a bunch of use cases like that we're doing. And next slide, please. So there was an example in our slides, and I'm not actually going to go through this because It's a little bit too detailed for this thing, but there is a recording. You could come back. But there was a really good example. Next slide, please. And really good slide here of the example of you had an autonomous car. It was generating a lot of data, and when it needed to upload it regularly. And so the idea was that it would be able to, for instance, do EAP TLS with client-side certificates and mutual authentication, which is the next slide, please. And so the idea is that you do that. So this is a common thing. If you ever have done Wi-Fi from your laptop and your enterprise has given you a P12 file to load, then you've done mutual TLS with EAP TLS for onboarding. And that's a common thing today. It's just like we don't do it at the IETF at the meeting because managing the certificates would be too hard, but we could have done it if we did it if we had it in DNS. Next slide, please. Go ahead, next slide. I said I'm not going to use all the slides. So in this example, the servers are authenticated with one set of names, and the clients are authenticated with a different set of names. And you don't have to go through a whole bunch of PKI operations to figure out what those names are, that they're just DNS names. Next slide, please. So where are we looking at putting this? Okay, so the working group's been around since just before the pandemic, and I would say that the pandemic has kind of taken about 2 years of steam out of our work. And so we basically are looking through a bunch of different things, and we have an architecture document that explains how these different protocols would use client-side certificates, why they would use them. Can't go through all of that today, and how it would happen. In order to make this possible, basically the critical key piece that we needed to be able to say was when you make that TLS connection, you can already put, an FQDN, a DNS name as your identity. That already is supported. It's been supported for ages. The issue is, having done that, the server side of things is like, okay, what do I do with this name? And historically, what you do is you look at your configuration file, because you better be configured to use that thing, and that's all there was. And the concept that you should go look it up in DNS is from the message from the client to the server. Well, you could configure that, but it would be configuration. And so what we've actually introduced is a new TLS extension that says, and the name you're looking for is in DNS. So go look at it there. Next slide, please. So we also looked at some data at rest. So that was a TLS side of things. So pretty much all those previous things were all using TLS. And we then looked at some data at rest. So things that sign statements. So for example, a report from a MUD controller about the status of things. That might be something you would sign. Other statements about remote attestation, other things like this, they may be signable objects. And what you want to do is you want to sign it and then with a name that later on an audit system can pick up. So these names actually are, this part of it was less successful, and we've actually removed in terms of interest, and we've actually removed it from our architecture. Next slide, please. And that's really about it. I mean, I didn't go too deep because I didn't think that we had time, and I would love to take questions.
Yeah, thanks very much, Michael. Are there any questions?
If you want to see this again, I would suggest you go back to the video recording because it's much more entertaining several years ago. Thanks.
So maybe one question. So I think we definitely understand the motivation and the use cases, and I think you probably have got this question a lot. Is DNS the right vehicle for doing this? So do you see any problems?
Yeah. So I skipped that a little bit, or there was maybe a different slide deck that I could have used that had more illustrative things. The issue is that DNS is already it's already decentralized, and it's already, I want to say, accessible in the sense that anyone can go and get a DNS name. You pay a small amount of rent, and then it's unique. So that kind of accomplishes what many people need. They need a unique name that's long-term stable, that they control, and they don't have to keep, paying to host it somewhere else. So go ahead, please, at the microphone.
Yeah.
Hi, this is Vittorio Bertola. No, I just wanted to confirm that, I was part of another effort trying to put identity in DNS. And in the end, we sort of failed to get traction. This was aimed at the DNS industry, mostly the registrars and so on. But I think that the DNS is the right place to do this because, as you were saying, it's a global infrastructure that we have. So I think it's a good idea.
So 20 years ago, I was involved in an effort to do this, use DNS to secure IPsec. That was called opportunistic encryption. There's informational RFC. I'll get the numbers wrong, 4332 or 4322. I can't remember which one it is. In that case, we stored raw DNS, raw RSA keys in the reverse DNS. And the only reason it didn't work well is because NAT. People didn't actually have IP addresses, so they couldn't assert that they owned them because they didn't. They were, NAT came along and killed us. So, Christian.
Yeah, Christian Wittema. I have two problems there in your discussion. Is one, you mentioned casually using TLS mutual authentication.
Yes.
But there are lots of practicalities there. Like, for example, if you go to a web page, the last thing you want is authenticate. So you have to have mechanism to know when you shall authenticate to a web page and when you don't.
So I guess a piece I missed is this is not about web browser to web server stuff.
Yeah.
Right. This is about like SMTP, right? You want to authenticate the client to the server.
Okay.
Okay. MQTT, again, not HTTP transport. If it is HTTP, then it's APIs from your devices to your.
Basically, you can put that in your UI that says I explicitly want to authenticate, but yes.
Right. Yeah. So it's kind of baked. The fact that you're going to authenticate with mutual TLS, that's kind of baked into the use case of what we're doing, right?
And the problem is that my next question is about the DNS. The problem with the DNS is more and more used as a point of control by government, copyright enforcement, and what have you. So you don't actually own a DNS address, you rent it.
Yeah.
And the rent can be canceled if one of those authorities tells so. I mean, say, yeah, this guy is doing copyright infringement, cancel his DNS. And that is a big risk. Okay, that's a big security issue. Yeah. So I wonder how you mitigate that. Because, I mean, if suddenly that means I've lost all my contacts because someone doesn't like something, it's bad.
So, my experience with, enforcement like that is that it tends to go towards hosted DNS providers that are susceptible to their local authority, right? So for instance, we're in Canada right now. You may not know this, but notice and takedown is not legal in Canada. If it's notice and notice. So properties don't just disappear online because someone's made a complaint. It actually takes 2 layers of complaint, and there's other jurisdictions. So I'm saying you may have to shop your jurisdiction a little bit smartly to figure out what your risks are. But yeah.
But that probably should be part of the architecture and all that. I mean, or you may have redundancy, or you may have many things. But yes.
Yeah, that's definitely an operational consideration. I don't think we put a lot of operational stuff into our architecture at this point. Anyone other questions?
I think that's it. Thank you very much, Michael.
You're welcome.
So now we move on to the third presentation. So this will be online.
Hello, can you hear me in the room and online?
Yes, we can hear you. At least I can.
Great. And I seem to be able to click through as well on the slide, so that's great. Okay, so all working well. Wonderful. Well, thank you so much. Hi, everyone. My name is Sheetal Kumar, and I am very grateful to the DINRG chairs for letting me present some of the perspectives that I've been working on with colleagues on this topic, or these trends and themes of centralization, consolidation, and fragmentation. And we thought it would be of particular interest to this group because of the amount of work that's been done by members of this group on these topics. What we want to do is bring some clarity to where they connect as trends, and that's why the name of the presentation is One Ring to Rule Them All. So I hope to spend just 10 minutes on this, on the presentation, and then have time for the Q&A, an equal amount of time for the Q&A. Great. So moving on to the first slide, what the chart shows is what we have analyzed about the text available, the literature available on consolidation and centralization that shows taxonomic inconsistency in terms of the use. So they're often used interchangeably, but what we posit here is that while they do share some common points as trends or terms, there is also a difference. And it's particularly important to note that difference when it comes to asking what can the IETF do, or what should it do about these trends, and similarly with fragmentation. And that's what we really want to be asking here. Can the IETF do anything, and should it be doing anything? So as you can see on the slide, both centralization and consolidation refer to concentration of power, fewer entities having more control, and the implications that has for internet architecture and for end users as well. But what we've noted is that consolidation refers to more the market forces, so external market forces and economic forces, and centralization is broader and can be about facilitating architectural changes at the protocol level, which may then feed into and shape external forces. So it's broader in that sense. And that means that efforts to differentiate between the two really come down to whether the impact on the network and the end user arises primarily or solely from economic and market forces, or also from the design of standards and protocols. So that's consolidation and centralization. And then moving on to fragmentation. So what we've got on the slide there is, again, this is a contested term, but there are a couple of frameworks, the World Economic Forum and the Internet Governance Forum, Policy Network on Internet Fragmentation, have endeavored to provide frameworks to define or conceptualize what the term means. And I suppose really, you can look at the slides, but they have different components that range from narrow terminology to broader. And really it's about whether or not and to what extent data flows are enabled or otherwise, and whether connectivity is enabled. So it's about the ability for that to happen. And so anyway, there's a lot of differentiation there, but don't have time to go into in great detail. We also wanted to show you what we thought was relevant at the IETF recent meetings, well, particularly 117. There were a couple of presentations which dealt with the definition of internet fragmentation, and these are really one of them, the presentation by, I think it's John Heidemann and Guillermo Baltra, are really quite on the narrow end of the spectrum about connectivity of publicly available IP addresses. So if more than 50% can connect to each other, that means the internet's not fragmented. If that's not the case, then it is. So that's quite a very narrow definition. And then we had a presentation by Nick Merrill where he presented a way of measuring fragmentation that's around a set of proxy measures for different layers of the internet stack. And really, I think what's interesting about his proposal or research is that it shows how internet fragmentation, or how the internet is being shaped by geopolitical forces and control points, which are really about concentration of power in fewer entities, particularly US-owned companies, and how that affects how data is routed. And then we found Mallory Nodal's ID on GitHub, also very useful, because that's a bit broader. Perhaps it's talks about how norms around connectivity and what does meaningful connectivity mean, and whether or not it might be useful to have a framework for understanding whether a proposed policy could tip a network from being open to not open. So a bit more like on the broader end of the spectrum there, perhaps. So moving on, well, there's actually more of that table. That table didn't all fit in, so there's more there. Yeah, there's more about those presentations, but bringing us to the second part of this presentation, really, which is what has this got to do with the IETF? What have they all got to do with each other? And what we find is that they share a common concern about concentration of power and resources. And this is of concern because of the impact it could have in time on the stability of the network, of the internet as a whole, and could impact its openness as well. So what's missing is an analysis, in our view, of how protocols and standards could impact control points, whether by augmenting their control or diminishing it or being neutral. And what we think would be instructive is to consider the end user in all of this as a starting point. We wouldn't be starting from scratch if we did that, because there are existing principles, including the end-to-end principle, and RFCs looking at how it's evolving. But we think that focusing in on how the end user is impacted and bringing together other frameworks could be helpful to answer this question. So moving on. Oh, yeah, so this is a kind of provocative. This is a slide that is maybe, I suppose, just trying to make the point that because regulation and policy is impacting standards and vice versa, standards development is not happening in a vacuum, and we think it would be helpful to consider how the end user is being impacted by standards, but particularly when we're looking at what impact could it have on the concentration of resources and control points. So moving on, so this is one of the existing frameworks or pieces of the puzzle we think could be brought together in a wider framework to help us answer that question of what could the IETF do. And I'm coming to the end. Basically, we know that the end-to-end principle is evolving, and we think that there are certain aspects of it that we need to pay attention to in the development of protocols. So some of the text on this slide explains what I mean by that. And then there are RFCs that really look at this in more detail, of course, how it's evolving. Those are in the ID as well that we published on GitHub. But here's where we think it would be really interesting to get your views, and I have some ideas of next steps on the penultimate slide. Could we have a framework that's looking at is user choice, agency, and control preserved in the development of its protocol? Are we considering user rights? What is the impact of choke points or control points or single points of failure potential? And are we preserving the core principles of the end-to-end principle? And that could be the beginnings, or it could be some, doesn't necessarily have to be a framework. We've got feedback as well that maybe this could be like a messaging framework instead. But these are the things we think bring everything together and bring us closer to the question of what the IETF could consider when it comes to these themes. And again, that central point of concern around the concentration of resources in a smaller amount of entities and the potential for that to create single points of failure and reduce the openness of the internet. So here are some questions for everyone. And I really, encourage everyone to look at the ID if it's of interest. And there are some use cases in there. Some of those are more like policy ones. But some of those are also about whether or not, for example, standards that could impact net neutrality if deployed. There are I think, a range of use cases there. But what we wanted to do with this presentation was just really present some of the key points and that core point about what unites all of these frameworks and concerns, and ask whether there would be interest in building out a framework based on this train of thought. So let me end there and open up in case anybody has questions.
Okay, thank you very much, Sheetal. Do we have questions?
Or comments, or people who think this doesn't make any sense?
Yeah, no, we have a few questions coming up. So we have Andrew Campling in the queue.
Hi, Sheetal. Andrew Campling. Thanks for the presentation. Personally, I think the sort of centralization and consolidation are really important. I'm skeptical about fragmentation, but then you didn't really cover that so much, so that's okay. I think RFC 8890 is quite relevant here in terms of the internet being for the end user. I think that's probably the most important thing that this community could reasonably say. I suppose the question is whether, though, that this community has any competence to say much more than that, because it's not multi-stakeholder, and it's arguably probably other places that have the most competence and capability to say relevant things that perhaps could then inform actions that the IETF might then reasonably want to consider and take, as opposed to actually the IETF itself making those decisions. So it'd be more a receiver of decisions, perhaps a convener of the discussion, but not necessarily itself able to make decisions, if that makes sense. I don't know if you agree with that or think differently.
Mm-hmm. Yes, so actually that RFC that you just mentioned, it also says that inappropriate concentration of power on the internet has become a concerning phenomenon, one that protocol design might have some influence upon. And that's where, you know, that's the starting off point for the question, I suppose, or answer to your question, which is doing something, what does that look like? And it could be discussion, through more research that casts more visibility on what it means for protocol design to either augment or diminish, for example, that concentration of power. So, I mean, these are just sketches of ways forward, but I suppose what I'm saying is, yes, I think we could do something, but the IETF wouldn't be making like decisions, but we could bring something to the table. Yes, I know there's a lot of people in the queue, sorry. Go ahead.
Hi, Arnaud Tadei, Broadcom. So hi, Sheetal. Sheetal, I have two questions. One, some time ago, you organized a very good workshop between a couple of parties, and I wonder if you could consider bringing the report of this workshop to this community here. I think it was really a good job. And the second point, so basically what you are saying is that, I think it's a question for DINRG here, is how do we continue the work here, and by which angle we attack it? So your proposal is basically to say, I think it's the previous slide, you want to keep it as a user-centric, yes, centering the end user. So basically you propose to find solutions that we center on the experience. And okay, is this what you are trying to propose, right? Okay, thank you very much.
Hi, Sheetal. This is Vittorio Bertola, and yes, I had a comment, but I think it's maybe more for the room than for you, because I mean, I think we generally agree with these principles. Yet, if we then go and look at the output of the IETF, there's a continuous churning of new protocols that do the opposite stuff, like ARC, that by design expects there to be a limited number of, trusted parties that are the only ones that can actually use the mechanism, or like the oblivious mechanism that again centralize everything into very few operators that are big enough to provide the infrastructure. So my wonder is actually how can we make it so that what we discuss in this research group, in this part of the IETF, also goes into the rest of the IETF, because I think that that's what we are failing at. And the other comment is about the end-to-end principle, which of course we all share, but I think that we often fail to realize that the end-to-end principle was conceived in a moment, in a period in time in which users had full control over their devices. So the end-to-end principle is only between the interface on your device with the network and the other interface. Today, I think the users are faced with mostly adversarial devices like mobile phones. They don't really let you do whatever you want. Actually, they push you to do certain things or not to do others, and they control what you can do. So we should, I think, rephrase the end-to-end principle, like from the hands of the user and the eyes of the user to the other hands and the eyes of the user, and start thinking also at how we can protect the user from the devices that now are trying to push them to do things that they don't want to do.
So,
okay, Rahul.
Yeah, my question is, if Rahul Gupta, have you considered the effect of the larger computing market on centralization that happens on the internet? So we see that the hardware is in a sense centralized. There are very few players who make hardware. In many application areas, software is as well centralized, and that has ramifications for the internet. I mean, the CrowdStrike example is perfect for that. So how do you intend to incorporate this into an understanding of how centralization is occurring on the internet?
Answer the questions here, or shall we let Mallory come in as well? I don't know how much time we have.
It's up to you.
Okay. Mallory, do you want to go first, and then I can just take the questions all at once?
Sure, yeah, no, thanks for the presentation. I just wanted to articulate why I think that this work is so important. We see, if we just look at efforts to combat antitrust and consolidation of the big tech market, we get anti-patterns where the end user is cut off from receiving, privacy-preserving features, like in the case of the UK's ICO stopping Google from rolling out Privacy Sandbox. And that just gives Google an excuse to kick the can down the road on the things that they've been promising for years and years and years. So and part of this, right, also happens in the US and other places where the antitrust efforts are actually just the government picking sides in the tussle between big tech network and big tech service. And of course, right, the people who are losing out are the rest of us, right, that aren't big companies on either side. It's not marginally making things better. I would also point to, sender pays framework in EU and South Korea. There's loads of efforts to try to correct either the centralization or the consolidation, both the technical and then the market, that are just leaving the rest of us out. So while I also have for many years agreed that fragmentation is not a perfect term, I think it is the closest one that describes the fail points for people. And yeah, end user also is an imperfect framework, because I think a lot of these effects are bigger than just how it impacts the individual, right? It impacts commerce and competition, it impacts human rights, it impacts much bigger issues. So it isn't just about the end user, but I think the best place to start is by looking at this from the vantage point of the endpoints, because that gives you a different picture and it gives you different incentives and how those interventions then can correct these negative effects. So thank you for your work. And I'm sorry that was more of a comment question, but you said you wanted statements of support, and I just wanted to lend my support to your work on this. Thanks.
Thanks, Mallory. That's really helpful. And I think there's a few things here that if people do want to work on next steps or putting this together in a less sketched out way, that we can definitely incorporate. Just want to respond to the question about, I think it was about hardware. And I suppose, there's, those kind of what are seen, it's really the principle of the lack of interdependencies, rather, not lack of, and concentration therein, that we think this this group could deal with. And it might then, if we do that work, highlight areas where, you know, the hardware supply chain could also take lessons from this approach. Andrew, to your point in the chat, I think, you know, that the whole reason why we're proposing this more holistic approach that brings together all of these different aspects and principles and frameworks is precisely because just looking at it from one vantage point isn't having the desired impact, and is impacting the openness of the internet. So we think, you know, we bringing together these frameworks is ideal. And I haven't been able to follow the chat as I've been speaking, but yeah, I thank you all for your attention and for all the comments, and happy to take this onto the list. The contacts are on the last slide, and so it's the ID which has much more in it. Oh, thank you so much.
Okay, thanks very much, Sheetal, for bringing your work to DINRG. If you have anything else to share, also, for example, the report that Arnaud mentioned, just feel free to send a message to the DINRG mailing list. And thanks again. Okay, let's move on.
Yeah, we'll move on to the fourth and the last presenter to talk about, give us an introduction of Solid. I think that Dirk will have to drive this last presentation.
Wonderful. Thank you. Can you hear me well?
Yeah.
Thank you. I'm Hadrian Zbarcha. I'm the co-chair of the Solid Community Group at W3C. I put together some slides quickly. I didn't know I was supposed to present. Actually, Rahul Gupta, who's in the audience, initiated the contact with, I think, Lisha. But I'm here, so I'm going to talk a little bit about Solid. It's my first IETF, as you can tell, and I want to start with thanking you. You're a very welcoming crowd. The reason I'm here is I'm going to talk about this a little bit more. In Solid, we deal with a lot of things, in particular notifications, and we would like to reuse as much as possible the great work that IETF did. Of course, we deal with identities, addresses, routing, and all that kind of stuff. So that's why I'm here, and I'm glad that I saw this presentation about dance, because we're looking at that as well. So anyway, as you can tell, I forgot to put my name on the slides. I don't know if Dirk is going to give me an opportunity to update them later and add my contact information. But if not, you're going to see it in the minutes, and it's easy to find me on LinkedIn or other places. Thank you. The Solid standard was started by Tim Berners-Lee, and he has a very optimistic message, but that I subscribe to, that the future is so much better than the past. He started Solid in around 2013 to 15, and he worked on it at MIT, then at W3C. In 2018-19, he started DINRG, and I worked for DINRG to commercialize the Solid solutions. Right now at W3C, we are in the process of forming a working group, and we hope that's going to finalize around end of September, around TPAC. Next slide. Thank you. So I think all these issues about the fragmentation of the web and silos and all that stuff was discussed. So there is at IETF and other places a lot of discussions about data, but it's mostly data in transit, right? Part of protocols and all that. We don't talk a lot about data at rest. And I think in this area, the web innovations stagnated. If you can go to the next slide, we talk about silos. What we mean by that is that we talk about, you know, the DNS and addresses and services and TCP/IP and all that, but we don't talk much about what happens with the data, right? So we interact with services via all sorts of protocols, and then services store data in usually databases or file systems in the backend, but that data is not really usable by anybody except for the entity that collected and stored the data. Short example, it's impossible to address a row in a table in a database of some entity that operates a database. There are no protocols for that. It's impossible. And even if you had, let's say, connections to the database, you would have to be aware of schemas. Is a mess. So this issue of making the data available is one of the concerns of Solid. The other one is having control over the data. So that's what we mean by silos. I hope it's obvious. My observation is that Solid is much easier to explain in hindsight. So I was thinking maybe of giving you crowd maybe 5 minutes to figure it out, and then I'm gonna explain it. It's gonna be much easier. But anyway, next slide, please. Yes, so this is from the technical report. What Solid is a set of specifications that provide applications with secured and permissioned access to externally stored data in an interoperable way. This permissioned part is probably the new part, and I don't know if you have more questions about that. I'm going to try to touch on that. So like I said, today we interact with services, with applications, and the applications with services, but the data is hidden in the silo. The Solid approach, it kind of reverses all that. Instead of having databases that are structured in a way to serve the application and make the application performant in serving content, we promote a way, it's kind of a new paradigm, in which data is stored in solid pods, and it's more like, if you want domain modeling, it's application independent. You're gonna see in a future slide that I mentioned that what Solid tries to do is separate identities from storage, from applications, and actually we built on technologies for identities like the ones that Kalia mentioned earlier. So I don't think Solid is that interesting. I mean, the side effects are the important ones. By doing this, if you are an enterprise, it doesn't make, let's say, a lot of sense to use Solid because the whole enterprise already has access to the data in their database. It's a full control over it. The problem is what happens when you want to share it with other entities. So it works very well for enterprises that interact with other enterprises, or people who want to interact with enterprises, or people who want to interact with people and share data. So when you build the first application, basically the pods become sort of a backend for free for your application. And if you don't need some additional things like indexes and all that stuff, you basically don't need the backend at all, because the Solid protocol gives you access to the data. That's maybe not that interesting, but if you build the 10th application feeding from the same data, or maybe 80% of the data is already available to you. So the costs of building applications in the Solid model is much more effective. So what happens when you have the data available? How do you share it with consent? Of course, we use identities. We do not have our own identity model. We use identity models. We are looking at using DIDs right now. They are not used by Solid. There are historical reasons, because when the work on Solid started, the future of DIDs was not really certain. And we use WebID, which is another spec at W3C. But now we're looking at supporting more identity models, not just WebIDs, DIDs being the first suspect. Let's move to this, the next slide. So yes, that's what I mentioned about separating identities from applications from data. So identities, we use the same model, Web ID uses the same model as DIDs, in the sense that you have a unique, global unique ID, and then that resolves to a profile document that gives information about who you are, what the IDP you use. We use OIDC, by the way, what IDP you use, what private keys you might have, and what storages, meaning data pods you control. We also use linked data. I'm not going to talk too much about that unless there are questions. And as I mentioned before, applications can connect. Applications actually use a user identity, and via OIDC and one of the trusted IDPs can authenticate and then be authorized with whatever credentials they have to access the data, the pod, and the data in the pod. And different users, different entities might have access to different kinds of data in the pod. As I mentioned, I think the Solid becomes more interesting once you have more applications feeding from data in the same pod. And another interesting side effect is that Solid allows this way to create, if you want, data supply chains in communities. And that's one of our main goals. Next slide, please. Yes, so that's probably a summary of stuff I already mentioned. User centric data. Pods are extensible in the sense that I'm trying to make an analogy for this crowd. So in a way, Solid is a more general web dev, if you want, right? Web dev was used kind of in the same way to get access to data in a web dev service. So Solid is indifferent, is agnostic to what data you put there, right? You can put your images, you can put your medical records, you can put whatever data, right? So that's governed by vocabularies. As I said, it's sort of like the domain modeling, and then it can be shared. And because users control data and they can share data, they become active participants in a data supply chain, and they share decisions about what data is shared. As a bit of an aside, the fact that you control access to data doesn't necessarily mean that you control the data itself. There are some edge cases. We have governments in production, for instance, who provide pods to citizens. Actually, I can talk a little bit about this model. They kind of reverse the model. Instead of having multiple agencies all having their database, and when you interact with an agency like DMV in the US and you change your name, get a new driver's license, but other agencies don't know about this data, Solid reverses the model, and some governments use this in production to give a pod to every citizen, and interactions between the government, any agency, and the citizen are reflected in that pod. Meaning that if I go to the DMV and change my name, any other agency has access to accurate information, because the data comes from the citizen's pod, not from the agency's database. But what I started to mention is that while you have control and you know who requires access to the pod, and you can authorize that access or not, it doesn't necessarily mean that you can change the data. For instance, if you have a ticket or a criminal record, doesn't mean that, I don't like it, I'm gonna go and remove my ticket because it's in my pod. So there are a lot of very interesting use cases to build with Solid. Next slide, please. So that kind of reflects what I just said. You can have multiple pods, multiple providers of pods. By the way, there are, I think, 6 or 7 implementations of Solid already. 3 or 4 are open source, and I think another 3 commercial. So it's already in production. And one entity, could be a person, a user, or could be something else, can have one or more pods. They can use one or more identity providers. You can move a pod from one place, from one provider to another if you don't like to, if you like to. And then there are applications that feed, basically read and write data in these pods. But we hope to come to a new model. Next slide, please. When then you're gonna have what we call a tier 2, a number of applications that provide additional services based on data in the pod. So a more concrete example, for instance, would be because data is in silos today and you have your bank records at the bank, you have your, I don't know, what you buy is in the databases of the grocery store, or medical records are scattered among hospitals. While these entities have the tools to write all sorts of algorithms, including an AI, to use that data, we as individuals have no means to access this data in multiple silos and write or buy algorithms, execute algorithms that allow us to correlate and provide value to us. So this is what Solid provides, and that's what we hope is going to happen with these tier 2 applications. We hope a new wave of innovation is going to come that allows people to build applications that correlate this data, because now it's available from pods. Next slide. And this might have been probably the last.
I think that's the last slide.
Yes, okay. So I don't have a thank you slide, but thank you anyway. And I'll open it for questions. And if there are none, I think that leaves more time to the panel that's going to follow. Thank you so much.
Thank you, Adrian. Do we have questions?
If I ask a question, you mentioned earlier that identifiers are outside of the solid design. That'd be separate tasks outside the solid design.
Yes, well, and I mentioned notifications as well. Yes, so we try to reuse the best of breed protocols and technologies out there. I consider Solid more of a paradigm, and there are if you want, specs part is the part that complements or puts together the protocols we decide to use. But yes, we are not trying to reinvent the wheel. We're trying to reuse best of breed protocols and technologies. And in particular for notifications, I'm really looking at this crowd to give us some advice and help.
My question is actually how data are identified, given now they are application independent.
That's the interesting question. Yes, a very good question. So because data is in a pod, the pod actually is identifiable, uniquely identifiable globally, and data is uniquely identifiable within the pod as a namespace. So the combination of the two uniquely identified data. There are other models we're exploring, but that's what we support today.
Okay, so that is data is identified by the containers, the pod.
Today,
okay.
Yes. Actually, you kind of have to do that anyway. We do that with domains, and there are better models that we are exploring, as I said.
Thank you.
Hi, Gerald. So your model provides protection for the data that is inside the pod. Sorry. And so when it's at rest at the destination or whatever is a system that is storing the pod, so you can issue as many pods as you want. You can send it to different destinations. That's correct?
Sorry?
And you can encapsulate your data through pods,
right,
and send them to different destinations.
Well, you send basically an address, but yes.
You send a what, sorry?
An address. So then a requester can request access to the data, and you may get it or not.
Okay, but does the data ever travel somewhere else once it's in the pod?
The
it moves
data, at some point, yes. You cannot. It's getting a bit complicated, but to address your exact question, yes, at some point data will be transferred on request if there is an access grant to the requester. So a copy will be made. I think I know where we're going with this.
Yeah, so my concern is not so much on the transit or when it stays in the host, it's at execution time. So once the data is being executed and you don't have any way to verify what the software that is using that data may or may not be doing with the data itself, all the protection that you have in the previous steps seem to be disappearing. Because if I want, for instance, so part of the protection that I always understood Solid was trying to do is to give you your own sovereignty across your data.
Correct.
And you should be able to determine whether you want your data to be copied somewhere else or not. And so at execution time, my concern with Solid has always been, but that may be because I don't understand the protocol in full. That's why I'm asking the question. My concern has always been on the last mile. So in the execution time, what happens with the data that doesn't have knowledge that it is data and that have no knowledge that is being copied?
So it's, in my opinion, it's very hard to talk about this without talking about the concrete use case. Because I would say that, and I agree with you, by the way, but I don't think Solid is the only thing you should rely on, right? So in the world of decentralized internet that we all, I think, agree with its premises, right? So some people talk about identities, very good conversation. Some people talk about, well, Solid talks about storage, but it's not, identities or Solid are not gonna solve the problem end to end. So we talk about client-to-client protocols and other things that are gonna be layered on top of Solid to provide protections like the one you ask about and some other features. But Solid is not providing a 100% answer to what you addressed. And actually, we talked with Lisha 2 days ago about that. But yes.
Okay, I just wanted to make sure if my understanding was correct.
It is correct. But for instance, Lisha asked, if you make a copy of the data, I don't have control over it. That's very true, but the data changes, right? So if a good example would be a calendar. And what I mentioned as client-to-client protocols are kind of like CalDev in relation to WebDev, right? But the calendar changes. The fact that you access it and, okay, you made the copy, whatever trust model you use to trust that the data in the calendar is correct or accurate, the fact that you got it and you store a copy doesn't really mean much because the data may change. But again, it depends on the use case.
All right, thank you.
I hope that answered it.
Thanks very much, Hadrian. Sorry, I had to close the queue. We have to move on with our agenda. Thanks again for coming. And if people have more questions, please use the mailing list or meet Adrian in the hallway.
Yeah, thank you a lot. I think we're going to continue the discussion. Maybe some of the questions can be raised during the panel discussion. So this time, we welcome the panelists up front. I just put a few chairs here. Come and talk. They're going to upload the questions that we're going to start the discussion on.
Okay, so I cannot see the panel itself, but okay, let me just introduce it a little bit. So we wanted to use the rest of the time to have a discussion with invited panelists, but also everybody else in the room about potential next steps for DINRG. And so our panelists are Jeff Houston, Christian Hutemer, and Arnaud Tadej, and Elisha and I will moderate a little bit, make sure that we keep our time and that we also involve the rest of the room correctly. So we have about half an hour, and so we have to keep an eye on the time a little bit. Let me just introduce the panel and the idea to you. So we had quite interesting and lively discussions at previous DINRG meetings. And so sometimes these were also a bit like a spontaneous conversations. So many good points were raised, quite interesting and insightful. But sometimes the discussion really went into a diverse direction. It's quite challenging then to identify like common like directions, common topics. And so we want to use the time today to reflect a little bit on that and so continue this discussion, but maybe focus a little bit, say, on the topics and also the like the DINRG original charter that we updated last year. So the goal of the discussion is to ideally get a list of issues for DINRG and maybe a little bit more structured agenda for the upcoming work. So what we will do is we will discuss around 3 main questions, and then for each question we start with the panel discussion, but then also open the queue for the mic. So if you want to get engaged, please join the queue or line up at the mic, and we'll make sure that everybody can be heard. So let's just directly start and discuss the first question. So we talked a lot about centralization. What does it actually mean? Economic consolidation, concentration versus infrastructure centralization, and so on. And so we're wondering a little bit: do we actually think that we have a good understanding of the driving factors, so the economic factors, the technical, maybe all the things that are happening in regulation, legislation? Has the landscape changed recently? Is there anything else that we kind of missed or that we should take into consideration? And I think any other things that we should study more that we didn't pay enough attention to. And let's just start with this first topic now. And I'd like to open up the floor. So I think, Lisha, you have to moderate and pass the mic around in the room.
So I guess we're going to start from the first question, right? Yeah, and the panelists, please, whoever wants to chip in, just start talking. We've got the 2 mics up front.
People are pointing at me. My name's Jeff Houston. Look, I'm actually not sure we have a good enough understanding of many of these factors around centralisation. I believe that most of them are, oddly enough, economic in nature, and the technical drivers are certainly odd, and it's not the protocols we build. To be frank, what's driven the last 30 years and completely taken most conventional economic models by surprise has actually been Moore's Law. That the onslaught of reduced cost and improved speed in the fabric of computing has created unique business challenges and unique economic challenges that actually require a degree of economic agility in order to stay ahead. The rise of venture capital-based funding, incredibly high risk, and it needed ample surplus within an economy to fund and sustain it, was relatively unique in the US economy and not replicated in Europe. The twin circumstances of the onslaught of Moore's Law on the technology base and the requirement for vast amounts of extremely high risk investment led to a skewed outcome where you saw centralization in one part of this world that very quickly assumed overall dominance in markets globally. And I must admit, how that happened is now almost of historic interest rather than current interest. Moore's Law is coming to a halt. We can't continue this doubling without venturing into physics that we really don't understand. And the constant ability to maintain the pressure of every 18 months, it just doubles, doesn't seem to be an immediate future option. We're going to slow down. What does that mean? When the music stops, the folk who are sitting remain sitting. The folk who don't have a seat don't have a seat. It's as simple as that. And so the state of the system is what it is. And when Moore's Law grinds to a halt, the ability to alter that no longer requires high-risk venture capital. It simply favors incumbency. So I think the understanding of those radically different forces which didn't really have an historical precedent, is something that has not been studied in other disciplines. And the centralisation outcome, I think, was inevitable and was almost irrespective of the aspects of the technology. Is there anything the IETF could have done? Not really. Is there anything it could have done differently? Not really. It wasn't theirs to control. What was there was that Moore's law opened up an opportunity to unseat the incumbents in the telephone industry, and high risk, high volume capital coupled with Moore's law took it over. That was always going to happen. It had all the inevitability of a brick thrown out of the 50th floor of a high-rise building. It was going to fall and hit the ground. No other outcome. So from my point of view, there is much to study. It's becoming historic, I think, as we move into a different phase of Moore's law. And what's changing is indeed Moore's law is changing, not us. So that's my view.
Is that what? Yeah. Yeah, the good thing about Jeff is that he's really optimistic.
Thank you. I try.
So I kind of agree with you. I mean, definitely, I mean, there is a trend and more requirement. We saw that with the rise of the cloud. And the rise of the cloud is basically, how can I get all the computing of the world moved from computers that people owned to platforms that are owned by the big companies? And the selling message was, I mean, there are kind of two. There's one selling message was, it's easier for you if you move everything to the cloud, as in you don't have to pay a bunch of guys to manage computer, we do that for you. And also it's safer because suppose you have your DNS server in your basement, you're going to be taken out by a DOS attack in no time. Suppose you run your own mail server using, say, Microsoft Exchange. Well, you can have a phishing attack. You can have something like that. But if you move to the cloud, well, that was actually the sell point. The big company are going to secure their service really safe, and none of that will happen. May or may not be true, but that's continuing. And look at what's happening with AI. It's a typical application of what Jeff was saying about economics. It turns out that training this big AI model is only possible if you are ready to blow a couple of $1 billion. So the only guys who can do that are the guys who actually have access to a couple of $1 billion in funding to blow on a single model and redo it again and redo it again. And the net effect is that they end up with these models which are very, very powerful and that nobody can replicate because you don't have the same access to capital. And the net of that is we get further centralization because the venture capitalists and investors generally have pushed investment, and the model is always the same. Push enough investment quickly enough that you dominate a field, and then use the revenue to push it further and further, creating some kind of an avalanche of resource and blocking avenue for everybody else. So I'm optimistic too, Jeff.
Thank you.
Thank you. So Arnaud Tadei, Broadcom, when Lixia asked me to come in this panel on Sunday evening, I said reluctantly yes, and then suddenly I see, boy, there is Geoff and Christian on the panel. I mean, what the hell am I doing here? Anyway, so I come here with two sides. So in my job, I'm a global security strategist at Broadcom, formerly Symantec. And I do speak a lot with executives of the Fortune 100 and especially the top 10 banks and so on. I do a night job, which is I spend sometimes in IETF, but mostly in the ITU. So in the ITU, who I have in front of me is not tech people like us here, but is regulators. Next week, TISAG happens, 85% of the people will be regulators. So maybe we have two optimistics on my left. Maybe I'm the romantic here. So when I walk in the forest, I like to see a forest that is wild enough. I like big trees, smaller trees, and I hope that this whole ecosystem can, sustain each other and develop diversity and so on. But fortunately, that's not what happens. I think Geoff and Christian are very right. It was predictable that what would happen by the brute force of all the economics, finance, and investments, and all of what they rightly explained would lead to where we are now. That means a centralization and concentration. But there are some other voices and other forces at play. I will try to give you a few examples. The first one is on clouds. And I think what is fascinating is what happened on Friday. The chaos that happened on Friday was fantastic. So I have some of my customers that telling me, and I'm talking about the third largest bank in the world, say, we are rebuilding our data centers. That was before what happened on Friday. We are rebuilding them precisely for the fact that they want to have independence from the hyperscalers on the cloud, and they say, nope, we know the price is going to cost us, but this is about our resiliency in the long term. And all of the promise that happened from the cloud, yes, but it costs a fortune because there are other forces that are imposing, I don't remember what is the profit margin they must have, 60% profit margin minimum. So today, if you run a business and you are at only 20% profit margin, your owner will offboard you. That's where we are in the new financial world. So there are new forces that happen because action means reaction too. The second group of people who are making a change, and I think that's the second question here, are the regulators. So you take, for example, the EU has created recently 2 acts. One is called DORA, and that's not the Explorer. Another one is CRA. So what this is about? DORA is the Digital Operational Resiliency Act. This is only about the financial entities. That's a very clever act because what they realized is that even each member state of the EU could not have the asset to measure, understand, audit what's really going on with decentralization. And they want to make sure that all the financial entities are resilient in the long term. So this is about risk management, contract management, cybersecurity, and a couple of other things. But the interesting piece is that it's not about the European Central Bank auditing the financial entities. It's much more sophisticated than that. They realized that they need to create a second parallel control point on the ICT supply chain. And when you read the text, you have an entire set of clauses on concentration, risk concentration, incident concentration, and so on. And that's not run by the ECB. That's run by the ESAs. They created a joint committee with an overseas framework by which they are going to have a funding to make sure they can control the ICT chain. It's a very subtle construction. I must say I've not seen that so far for a long time. But the point is that there are things that are changing because the market reacts to concentration. The resiliency problem is becoming bigger. And the regulators, some of them start to get in. So there may be some different views in the future by which we start to rebalance things. There are plenty of interesting side effects from that. I could discuss that if you want, that are fascinating to look at, but that would be my starting point.
Dirk, you want to talk now? I'll be the last one.
So, I mean, we have a few people in the queue. Maybe we hear from the people in the room. So the first one would be Jean-François.
Well, before that, maybe I jump. Maybe I jump in a little quick, so that talk about the left and the right. I think from the audience viewpoint, I'm actually on the left. You guys on the right, right? I cannot help commenting on the pessimistic viewpoints. I first of all agree with the first 2 speakers, but being in academia, we have to be pessimistic. That's our research is on, challenging the most challenging questions. Very quick. I think number one, the whole internet revolution didn't start with the necessity of Moore's law. I think it's the opposite direction. That is the change of the soft side of the architecture, whether you run telecom or whether otherwise packet switching, that drove out the internet development, which actually put a high demand on the computing resources. I think that facilitated the advances in silicon. Of course, this is back and forth mutual enforcement. The more power in computing resources, the better development or faster development of the new applications. And the development of new applications on the other side really pushed the network development as well. I don't know much about the silicon, but I kind of agree with Jeff. I heard that Moore's law seemed to get into its end. But as an optimist, I feel that the progress will not stop. I'm done.
How about hearing from Andrew?
Yeah, hi, Andrew Kampnick here. Well, I'm tempted just to briefly comment. I think people have been predicting the end of Moore's law for about 30 years, and here we are. I appreciate the point about physics does come into play at some point, but of course we've got the untapped potential of quantum to kick in next. So who knows? Anyway, the point I wanted to make, looking at the slides, the bit about do we have enough understanding of the factors? I think the thing which perhaps we don't fully have a proper understanding of is the incentives that are driving the big behaviors. Jeff, I think, touched on some of them. But you'd look at also things like sort of trade agreements, bilateral trade agreements, and that certainly had an enormous impact here. And I don't believe has been talked about in this community because it's not remotely technical. So I think that's something to bear in mind. And also the incentives that's driving some of the really big players to effectively have control of ridiculously high percentage of the global traffic. In some cases, I think some players that arguably could control the routing of 20 to 30% of global traffic. And I don't think we've really started to explore what the implications of that would be. So I think we don't really understand all of the incentives that are driving the behavior. And sort of sub-bullet point 3 under number 1, we probably ought to study more some of the longer term implications of the centralization because of those incentives.
Thanks. Any immediate reaction?
Yeah, okay. Yeah, I mean, I've been thinking a bit about this business of where does it go? And it's very clear that if you have, especially look at it from Europe, they see big American companies owning a lot of the market, making a lot of money, etc. So we are going to see reactions, and we are seeing them. I mean, basically, there will be political pressure, there will be a discussion, there will be fines and regulations. And that's happening. The hope was that there would be national champions that emerge and compete with the Americans. And there are some companies like that. I mean, you can see DigitalOcean, you can see Hefner and things like that. They have their little clouds. But it's not exactly a huge success. I mean, this business of national champions means, yeah, they're still there, but they're not exactly influential. So what's the next step? What will happen? What will happen probably is that power likes power. So politicians like power, and they see the power of these big platforms. So what's very likely to happen is that they are going to strike a deal so that the power of the big platform is applied in ways that please the local politicians and vice versa. And that's what we're going to see. That's pretty much what we're going to see if we don't actually do something about it. Because the natural trend, For example, you have all kinds, we see that in regulations like preventing piracy, which is actually about enforcing copyright laws and making sure that the copyright holders make money. It's a classic case of big business dealing with the government and using the centralization to make sure that whoever doesn't use the internet in the way they want gets kicked out. Platforms can do that. So we are going to see a lot of that. And that's exactly the kind of stuff that we will have to guerrilla against. I mean, guerrilla, my grandpa did that by in the wars, etc. It doesn't end very well for most of the guerrillas. Yeah, and didn't end very well for him either. So, for example, guerrilla stuff, we could see, we've seen all this presentation of decentralized platforms. What I'm not seeing is decentralized application that basically get power. So I would encourage everybody to say, hey, there are lots of applications that could be done, are not done. And would like to see that, like, Licia, you have ideas. Yes.
No, I just want to point it out. We collected all the previous DINRG meeting agendas. There are actually about 3 specific application, decentralized application designs.
Yes.
I think that matches what you are asking for.
Yeah. Yeah, we see some of that.
In this world where we got rid of a regulated communications industry and effectively rewrote a lot of the expression of public interest in terms of correcting obscene market distortions, and for anything less than obscene, we simply said, oh, well, they'll sort it out. It's just a market. Then what gets deployed is what makes money. And what makes money tends to be a bulk problem. And decentralized applications that offer few incentives for, if you will, massive commercial exploitation tend to wither and die by their very nature, irrespective of, how much bread they bake, how much, it doesn't matter. We are working in a mainstream market. Comms is one of the biggest markets in the world. And the fact that we've kind of fallen into this economic situation is no accident. It just is what it is. And so I admire the guerrilla actions going, we must resist. My 17-year-old leftist self says, yay, I'll join you on the barricade.
Well,
but the harsh reality of where I am in life kind of says, I'll just go with the flow.
Or eventually, my grandpa was saved when the American came. But without the Americans, it might have been hard.
Yeah.
Yeah.
But to rebound, if I may, on the guerrilla approach, when you see, first of all, back to the question, do we have enough understanding? I agree with Geoff. No, the answer is no. We need to investigate more. I think there are actions and reactions to. So yes, the main action is that this is what it is. I certainly agree with Geoff, but I do observe as well a number of reactions that are developing. Some are coming from the market itself because there is fatigue. There is plenty of things that should have happened that is not exactly working like the cloud people wanted. Actually, the regulators is sometimes doing good things, sometimes doing bad things. This is an area that we don't understand here because we do not have the regulators here. I could list you the entire DORA, CRA, NIS2 if you want. That's quite of a block of things. The interesting piece in it is that if we would study this a little bit further, we could see some interesting ways to perhaps see some guerrilla patterns, because I agree with Christian on the fact that power, and Christian and Geoff, that power lacks power. But at the same time, when precisely to address the point of the EU cannot have its own cloud business and market, DORA was exactly a reaction to that. To say, okay, I cannot have my cloud business, but I can still hurt you, Mr. US companies and other companies. And that's what they are doing, or they try to do. The side effects are interesting because it's not exactly what's going to end up with. And I think here we would have quite of a good research to do if we want to continue. That's one piece. The other piece is another one, and it's perhaps more the romantic aspect of it. Yeah, would have IETF have any weight on what happened? Probably not. But it's not just the standard part. Even when you build stuff, and when I started at CERN long time ago, with Tim and others on the web and internet mail, what I liked was to big stuff. I liked hyperscaling, and I liked all of that. But I learned one lesson from all of these I'm talking 1 billion LDAP servers and that type of thing, so big stuff. But I had to learn the importance of design and architecture. And what I realized, but it took me decades to realize this, I realized that there is an effect on how you design things, have an effect on your laws, your jurisdiction, on your regulation, as well in your ethics codification, and as well on the anthropology of what you are really building. It's not easy because none of us were trained on that. And I think here there is perhaps something that would help us join many dots that we've seen, but we are missing some kind of what is the red line to get us through.
Next in queue.
So how about we try to cover at least the second topic a bit, and then open the queue for additional comments or questions. So with this very optimistic start, let's talk about how we want to respond to decentralization. We partly touch upon a few things here, but maybe there's something more we can get out of this. So how should societies and markets react? Which groups and stakeholders should get engaged, or we should get engaged more? And also, whose interest do we really want to push, or should we be pushing? But also maybe what kind of counter-action could go wrong? So what maybe are risks that we need to be aware of? I open the queue, and maybe the panel can start discussing this.
So Jeff was saying that, and it's perfectly right, that in order to develop any kind of application, you have to make money. I mean, if you are building anything, be it a peer-to-peer thing like Mastodon, or some kind of distributed chat like Delta Chat or something like that, you have to make money. You have to make money to sustain your operation, of course. I mean, if you don't do that, you go nowhere. You have to make money to invest. Now, there is a problem of making money, is that you are also mentioning the 60% profit rate of the big company. It's a well-known economic factor. If you are competing on a market, what they teach you in classes of economy is that you are going to sell your product about at the price it costs. Not necessarily the price it costs you, but the price it costs to the less competent competitor on the market that is still in business. And your margin will be in the 10-20%. Because you are competing and everybody is saying at cost plus something to sustain the operation and investment. If you have a monopoly, the game changes a lot because you don't have to worry about the competition. Instead of selling at the price it costs, you can sell it at the price that customer might be willing to pay. So suppose, for example, that you're a baker. Today you're a baker, you sell your bread, you're pretty much selling at the price it costs, plus whatever it takes to pay the rent and all that. But yeah. Now suppose that you have a monopoly on bread, okay? And people have no choice than to buy bread from you. You don't buy bread, you die. So what happens? Well, you're going to charge the bread for the loaf of bread, you're going to charge much more than $2. You're going to charge 10 probably, something people can pay, just 1 hour of work or something. And they're still happy, they're still fed, but you are getting much richer than if you did not have the monopoly. And the same is true across the board. And that's the reason why the Silicon Valley guys want to invest a big lump of investment to conquer our market. Because they want to build a monopoly in a segment of the market that they can be like this single baker in town, not the one that have to compete with everybody. And when you are competing with them, at best you're getting this 20% margin. So it's really hard. So can that change? I think the only way it can change, the only thing we have seen things like that change is with the Sherman Act.
1990.
Yeah, I mean, it's basically you have to break the monopolies, otherwise it doesn't change.
Well, if I have a quick response, I think it's Winston Churchill said something equivalent to that. If you want to forecast the future, you better look up at the past. Look at how or when or where the Silicon Valley ventures started, especially more on this networking side of the story. Right? It took about 20 years before Silicon Valley actually noticed that the internet existed and took big actions. So there's a seed investment. Everything needs capital. We all agree on that. But the question is, where the initial seed capital come that actually can invest into a new way of doing networking? Yes. Don't look at me in a strange way. Go ahead.
I'll look at you in a strange way because this is a very old topic. America in the 1890s had just come out of a damaging civil war, but it was an interesting war. It was the first of the industrial age wars, with industrial killing the lot. It was horrendous for the country, ripped it apart in some ways. But the folk who learned were business people, because they understood that industrial processes transformed a lot of their means of production within society. You didn't need to have a small industry beside a coal mine in order to do iron ore smelting. You could move the coal by train. You could make large-scale industrial smelting where you had adequate, resources and labor. You were able to move things around and create massive industry. And the small number of folk that realized that became incredibly rich incredibly quickly, and the labor force became incredibly exploited incredibly quickly, and the social ills that were around in America in the 1890s were paramount, were paralyzing, and became a political problem. The Sherman Act was a counter to that tried to say eloquently that it's when you're big, the social ills are bad. Just being big is the problem. What you do is also bad, but it's not what you do, it's being big. And the Sherman Act was about busting big. Now, big business really did push back. And the first of the applications of the Sherman Act, 1910, against American Tobacco and one of the oil companies, caused a recession, a depression, an economic slump. And the politicians in America got dead set scared to ever use that hammer again. Ford and GM rose, massive monopolies, went unchallenged. In the early 1930s, those two companies controlled 70% of the global car market. America was happy. The rest of the world was not so happy, but it persisted, no one challenged. The Sherman Act was never applied. The only time it kind of resurfaced again was when the excesses of telephone monopolies became unbearable politically. And it was really an American problem. The rest of the world did not get there at that point, but AT&T certainly was. Oddly enough, when the Americans took on AT&T, it started a global switch to deregulate the entire telephone industry, the largest and most valuable industry of the late 1970s, early 80s on the planet, employed the most people, was the dominant activity. Ripping it apart, Sherman Act style, going, it's not really that you gouge customers. It's not really that you sit on and actually block technology. The problem is you're too big. So let's break you apart and make you small. So we're not going to prosecute you for your behaviors. We're going to prosecute you for your bigness. Tried it again with Microsoft, failed abysmally. Have been nibbling away at Google, at Facebook, failing abysmally. Because in some ways they've learned, as much as the rest of us have learned, that it's more subtle in the way power exerts influence in today's world. So how do you respond to that? I wish I knew, but more to the point, me knowing doesn't help. I wish governments knew. I wish we had a more agile public policy sector that could react. Because quite frankly, the way the EU is working, nibbling away with punitive fines, they're not punitive, they're not behavioural correcting. They simply actually encourage more of the behaviour they were trying to stop. So I'm incredibly pessimistic that we know how to respond. And the folk who possibly could respond, I don't think they have the tools. Because there's one thing politicians really don't like is pissing off voters. So banning Facebook tomorrow is not a political answer, no matter what else you might have in your arsenal. And therein lies the core of the problem.
So if I may, I would like to give a different view on that. But fundamentally, Geoff is right. It's just that there are tools that may, for example, who heard about the term theory of harm, a TOH? There are tools that the regulator can apply beyond the big hammers like antitrust law or Sherman Act or that type of things. It's interesting that they have not used them yet too much. And one of the issues as well is that the hyperscalers learned a lot what happened from the telephony and AT&T was broken apart. So when they build themselves in an intricate way so that if this should happen, it will be much more complicated for the regulator to détricoter, I don't know the term in English, to untie all of this construction. So it took perhaps, 10 years to deregulate? Probably something like this for the telecom industry?
Worldwide, it was 25 years.
25 years. So they are betting on the fact that it will take like even longer than that. And you can see all sorts of other attempts, for example, taxation. So you have the OCDE that started to say, we cannot get you on the antitrust laws, so we're going to try to get you on the money side. So they made this construction to force all the big companies to pay everywhere they are in the country, is 12.5% everywhere. And I'm sure the lawyers of these big companies are doing all what they can to undo this war as well. But it's not easy, and I don't know, again, I don't have all the answers, but to answer how should societies and markets react, and maybe back to the first one, I think there are more things we should study because a TOH is quite interesting object to understand. My company just acquired VMware, so I can tell you we've been under that for a year and a half. So been reading a couple of TOH. These are ex ante and not ex post as well. So there are a couple of things that could matter on the legal side as well. So again, to back up one, I think we could, first of all, better understand what is the weaponry that governments have. Why is it that they have not pressed the button yet? Or was there a deal when they did the OCDE to say, well, you accept the taxation and we stop continuing the antitrust law? I don't know. But there are things that we are probably not fully aware of what's going on. And on which groups and stakeholders should get engaged, where we should engage with the regulators. And if I want to jump on the next point, my point is that the regulators are not here. They are in the ITU. So the question is, and some people will hate me for that, but do we want to start to collaborate a bit with Study Group 3 in the ITU to get things, perhaps better information here? I'm just opening the
Is it a trade problem? So we have to wrap up really, really soon, but I still want to give the people in the queue a chance to state their comments or questions. We have Bengo first.
Hey, Bengo. I'm a Silicon Valley guy. But Mastodon was mentioned, and I also worked on ActivityPub starting 10 years ago. So I was thinking we could talk about that in terms of like how we should react and which interests do we want to push. And I would suggest that some of the interests we should push are the interest of human rights holders, not necessarily corporate rights holders. We take care of their interests quite a bit. They pay our salaries and stuff. But even Mastodon doesn't allow end users using the platform to choose a license for their posts. And they certainly don't let them put a cryptographic signature over the license in a way that would let them, would empower them to enforce their copyright interests when, in terms of what's changed recently, all the big tech companies are trying to make AI products out of nowhere, in part by literally scrubbing the licenses out of GitHub data, Microsoft. So one thing I would say is that we need to, for the sake of decentralizing the internet, decentralize the legal control over the information over the internet. not just the technical control. But the protocol designers, all of us, and cryptographers can help, and as well as the application developers and the user interface designers, by making reference applications that empower users to choose their license, or even more granular rights as to copyright. And to the end-to-end principle, get the data out of the middle of the internet and on the ends, by in part empowering users at the ends to put copyrights to prevent the big powerful companies in the middle and governments from monetizing their data. So I'm curious if anyone has thoughts on the importance of empowering human rights holders by empowering them to choose licenses over their data and make cryptographic signatures before they go into the network.
So it takes 30 seconds. Absolutely. That's why exactly I asked Sheetal about if she would consider that we should look at it from the end user perspective. Again, it's a romantic view because the problem we have no theory to include human rights in design. And that's the issue we have. So until we are able to do that, the problem is that other people understood the theory of design before us, and they chose a path for us. So now, if you want to try to go to another path from technology, law, ethics, and anthropology, which would get us to where you want, unfortunately, some people chose the path before us. We could have a chance to do that, but it's going to require a colossal coordinated effort from people to get to the position you want. I'm not saying no, I'm just saying just be mindful of what question.
Thanks, Arno. Let's move to Christopher in the queue.
I just want to comment on, kind of the assertion that Moore's law is going to end. I think yes, but no. DINRG scaling is getting a lot harder, but 3D chips, 3D systems are going to come online, right? I mean, we already have interposers. We already have systems that do this with chiplets already, and that's going to, I think, explode. But that's also going to allow particularly large companies to be able to build combinations of silicon that aren't generally available as kind of catalog parts, as what's known in the industry, which I think will, kind of lean towards folks who can build silicon combinations that suit their needs a little bit more. So I wonder how, would you guys change your answer under that version where, more custom, more powerful silicon, and then you have the power to invest in your own accelerators and have them integrated might change it?
I think the mic is not on.
One micron scale, and that's kind of rocket ships and quantum, which is fine. Someone might do it. I don't discount it. But turning the wheel and cranking out improvements every 18 months, not just not. We've reached the end of that particular robotic wheel, and the rethink this industry is the challenge. So over the next 10 years, the Apple innovation next year is not a faster chip. It's just like this year. And this year, like next year, you'll get MacBook Pros in purple. Same speed, same memory, same price, probably more expensive. But that's our innovation in this world. And that's why Moore's law is not causing more problems. There might be a breakthrough coming down the track. Someone might do 3D printing, but not tomorrow. In fact, not last week.
Okay.
Build the chips.
So I think the mic in front of Jeff is not working. But let's go on with...
Bring the mic closer to your mouth when you talk, Jeff, because he can't hear. This is Dino. I want to make a point about Moore's law, but I have more important points to make. Maybe we shouldn't characterize it as Moore's law because Jeff, you're looking at it as per unit compute on a single die. I mean, Elon is building a new model with 100,000 GPUs. So the compute power is increasing. It may not be per unit, but these clusters are going to become more and more powerful. So I'm not sure the doubling every 18 months on a single die silicon is really an important measurement. But the fact that Jensen at NVIDIA says that he can the next Blackwell chip that he's coming out is going to go 30 times the speed, and he did it in less than 1 year. So he's creating his own new chart that's going to be a little bit different. So having said that, then there was a point that Christian made about bread. You should never buy a pizza at full price. There's always a coupon where you can get it cheaper. People that don't collect coupons, those are high margin customers for those pizza makers. So the point there meaning is you can't price things too high, or we don't have the decentralized model where humans have power. If you can't sell to a large market because the prices are too high, you're forced to come down just to a point where they can barely afford it. And what's going on in the US now is nobody can afford anything, and they're going delinquent on their credit cards. And so it's the banks that are starting to fail. So that's one point. Number two, how can we solve this problem? You got to follow the money, Dirk. That's all there's to it. And why do we have somewhat of an open platform called Twitter/X? Because there's a billionaire that bought it. If you want the DINRG to help, you invite and convince Elon Musk to come here, because it's for the good of humanity to do this. And if he thinks these people aren't capitalists in this room, he may help us. Follow the money.
Okay, thanks, Dino. Let's see.
Could I go? George?
Sorry, Raul, the mics are not working anymore, maybe because we are over time.
Oh, okay.
Yeah, so what I'm saying is that if we focus on human rights, we can start the guerrilla part and we can win the mines. And winning the mines is the way you get the laws to change, and you can use the power of the state to mitigate the evil and open things. Yes. But I mean, I'm not sure that's the role of the IETF, because I mean, doing politics inside the IETF is not exactly what you want. I mean, that's the IETF is making sure that we have the technology to do what we want, and we should definitely do that. But hey, unless you go on the market and start the guerrilla, nothing is going to happen.
Okay. Very last question by Raul.
What happened with my grandpa? He was arrested to Gestapo, is what you want. Yeah, sure.
A very quick comment about Moore's law. Moore's law was actually Engelbart's law. Douglas Engelbart, the inventor of the personal computer, his law applied to microprocessors. And he had identified that you don't have to just look at the scaling of microprocessors, you have to look at scaling of all the processes in totality, and then see how you're going to, how that changes the situation, how that changes the environment. So just to put that into context.
Okay, thanks, Raul. So I think we really have to wrap this up because we are more than 15 minutes over time. Yeah, thanks very, very much, Arno, Jeff, and Christian. I wish we had more time. So Lisha and I are going to think about this. So we will have more time at the next IETF, but also at the CONEXT workshop that we are preparing. So that will be another format, so different to the 2-hour slots that we normally get at the IETF meetings. Maybe that's a chance to have a more in-depth discussion. For now, yeah, thanks again, everybody who was presenting, debating, and also sharing comments in the chat. Please keep sharing your thoughts and questions on the mailing list as well, and we will follow up and let's see what we can make out of this. For now, thanks everybody, and enjoy your lunch. Bye-bye.